Hi, I'm Mr. V, and today's lesson is from Illustrative Mathematics, which is our textbook. We're in right triangle trigonometry in lesson 5, working with ratios in right triangles. And for the warm-up, I've asked you to tell me some values for x and for y that would make sense. And this, you'll notice, is a linear equation, y equals 2x plus 3. If I show you on my smartboard, my whiteboard, I could set up a table of values, excuse me. And so for x as my input, I would have y as my output. If I chose 0, I get 3. If I chose 1, I get 5, 2, 7, 3, 9, 4, 11, and so forth. So there's a lot of different points that are actually lattice points, points on the grid that match up. And you'll notice here my change in x, my delta x is 1. And for every change in that, I have a change in y of 2. The slope of our line is the rise divided by the run. That is the change in y divided by the change in x, which is a slope of 2 over 1. So this tells you something about the linear equation and this relationship from our model. The objective of today's lesson is, by the end of the lesson, you should be able to say, I can use a table of ratios of side lengths of right triangles to estimate an unknown angle measure. I can use a table of ratios of side lengths of right triangles to estimate unknown side lengths. Those two things, to be able to estimate the unknown sides. Remember, in a right triangle, if we have two sides, we can use the Pythagorean Theorem. What we're trying to do is to find out the side lengths and the angles if I'm only given one side and one of the acute angles, one of the two acute angles. So in the warm-up, we have this. When a rocket is launched, it climbs 50 feet. For every 13 feet, it travels horizontally. Draw the diagram, estimate the rocket's launch angle using the ratio in the table provided. Now, for each of the questions, I'm going to go through all the questions for today, I think, if I have time, but I want you to try them on your own. So, spoiler alert, don't just look at my work, watch me do it. You should actually try this on your own. On my whiteboard, I'm going to draw a picture. So this rocket's going off kind of like at an angle like this. And if it's going up for every 13 feet horizontally, it's going up 50 feet. And from this angle, which is what we're looking for, we'll call this x degrees. I've got this side is the opposite leg. And this side is the adjacent leg. Now, hypotenuse is still the hypotenuse, and it's adjacent, but it's not the adjacent leg. Adjacent leg. And I've got a ratio over here that I can use for opposite over adjacent leg. Well, let's calculate that. The opposite over the adjacent, and I'll abbreviate it, is equal to 50 over 13, which is not in my ratio. This is a ratio. These are decimals. So I need to write this as a decimal. So this is approximately how much. Let's put it in a calculator. Do 50 over 13. Get 3.85, roughly 2 decimals is 8.85. And if I have to move me on this chart here, 3.85, that's not on the table, but it's somewhere over here, somewhere between here. So I could estimate it maybe 7.4 degrees or 7.5 degrees, 74 degrees, excuse me, 74 degrees. That's just an approximation. Our next activity, so after we talk about this, in this next activity, we estimate the measures in right triangles by calculating the side lengths, the ratio of the side lengths, and using the table. So instead of using just a squared plus b squared is c squared. And we're going to use Pythagorean triples, which have whole numbers for sides. Now, there's only 16 primitive or relative prime Pythagorean triples with a hypotenuse of less than 100. And there's only 50 Pythagorean triples total with a hypotenuse of less than 100. So you can put your arms around this. This is something that you can look at. Most right triangles are not Pythagorean triples. So these are only the real nice ones, if you want to call it that. So first of all, what does the Pythagorean theorem say? It says, if you have a right triangle and B are legs and C is the hypotenuse, then A squared plus B squared is equal to C squared. That's what it says. So if you have a right triangle, then A squared plus B squared is C squared. The converse switches those two arguments. So it says, if A squared plus B squared is C squared, then you have a right triangle. This is a short video you can watch which tells you how to determine if three sides of a triangle make it, if it's a right triangle given the three sides. So our activity is on page 10 by the converse Pythagorean theorem, which says if the sides A squared plus B squared is equal to C squared, then you have a right triangle. We know that a triangle with the side lengths 7, 24, and 25 is a right triangle because 7 squared plus 24 squared is equal to 25 squared. A triangle whose sides numbers are all whole numbers is called a Pythagorean triple. So sketch the triangle in the grid below, label the smallest angle A, then 90, and then the third angle. And then fill out this table and to figure out what to estimate for A is, and then find the angle B. So if I do this, I've drawn my triangle. I'm using the grid. So this is actually 7, and this is 24. This would be 25. My smallest angle would be A. We're told the right angle would be C, and this other angle would be B. And from angle A as my reference angle, this side go all the way across. We'll call this Y, and call this, no, wait, we don't need to call this Y. I'm going to say this is my opposite side, which is 7. This is my adjacent leg, and this is my hypotenuse. And when you do these type of problems, I strongly urge you to write op, adjacent, hypotenuse, or OAH, to make sure that you label the sides correctly. The adjacent to the hypotenuse, that's this one divided by this, is 24 divided by 25. The opposite to the hypotenuse is 7 over 24. The opposite to the adjacent, 7 over 24. Here, and this is 7 over 25 to the hypotenuse. And when you plug this into a calculator, you get 0.96, 0.28, and 0.29. On my graph here, let's see if I can make this a little bit like this. It's not on here. 0.96 would be, it's somewhere between here and here. 0.96, 0.28, and somewhere between, and 0.29, somewhere between here and here. I'm going to say it's about 15 degrees. And you might agree with that or might not, but I'm going to say that A is about 15 degrees. And these two angles would have to add to 90 because 90 plus 90 is 180. So this would have to be about 75. Okay. Let's look at page 10. Ready for more? Page 12, it says, what do you notice? What do you wonder? Notice there's a right triangle. Notice that the hypotenuse is the only side. It's given it's 8.5. The one angle is 20. So the other angle C must be 70 because they have to be complementary. I wonder what the other two sides are. Of course we do. So on the following pages are 4 problems, and it tells you some instructions on how to go about solving these. You're given space, you're given a drawing, you're given the table, and I'm going to show you on my whiteboard how to solve these problems. So from 20 degrees is my reference angle. First of all, I know that the other angle has got to be 70. But from this reference angle, this is the, go all the way across, this is the opposite. And I'm going to label it Y, so I don't have to label it CA every time. And this is the adjacent leg. And I'll call it X. And this is the hypotenuse. We know the ratios for a 20-degree angle. I know if I do opposite over adjacent, I'm going to have Y over X, and I won't be able to solve for it. So I'm going to use these two. When I do adjacent over hypotenuse, that's going to be X over 8.5. And the adjacent over the hypotenuse for a 20-degree angle is 0.94. So I could solve for X. It would be 0.94 times 8.5. The opposite over the hypotenuse would be y over 8.4. And that has a ratio of 0.342, 0.342. And I can cross multiply and get y is equal to 0.342 times 8.4. And you can put these into your calculator and calculate them to the 2 decimals or 1 decimal, 2 decimals, and solve it. That's how we solve it. The second problem, it says in a right triangle with one angle measuring 40 degrees. So I'm going to draw a right triangle, try to make it as right as I can. I'll label this as 40 degrees. The opposite leg of the 40-degree angle is 5. What is the length of the hypotenuse? So this is 40 degrees. I'm going to go down to my 40 degrees in my table, and I will say, So from the 40 degrees, the opposite divided by the hypotenuse is equal to 5 divided by h. And that's equal to this ratio of opposite to 0.643. 0.643. Now I need to, and I can put that over 1 if I want. I can need to solve for h, but h is in the denominator. So I'm going to cross multiply, and I get 0.643 times h is equal to 5. I want to isolate the variable. Here I'm multiplying. I'll do the inverse operation, divide both sides. So I get 0.643 divided on this side. Anything you do to the left side, we'll do to the right. 0.643. And this will give me a number. This cancels. This becomes a giant 1. You can stick this in your calculator and figure out what it is, how long that side length is. It should be longer than 5 because it's the hypotenuse, so it better be longer than 5. Here we have a triangle. Now you could turn this around and manipulate it so that it's standing upright if you wanted to. I'm just going to do it like it is. 50 degrees is my reference angle, this one here. Of course, the other angle must be 40 degrees. And from this angle, this would be the adjacent leg. This would be the opposite leg. And this would be the hypotenuse. Now, I don't remember which ones we were asked to solve for in this. Let me just look on the thing here. It says, find the side length DE. So we need to find this side. This is the one we're looking for. We'll call it X. They didn't ask us to solve for the hypotenuse. Well, I've got the adjacent, and I'm looking for the opposite. Which of these ratios would that be? I'm going to use this one. So 0.192. This is a ratio. It looks like a decimal. Yeah, it is a decimal, but it's also the ratio of the opposite to the adjacent for 50 degrees. Notice I'm starting at 50, not at 40. If I was 40, it would be the other line. So the opposite of the adjacent is x over 6. And that's equal to 1.192. And you could multiply both sides by 6 to solve for this. These two cancel, become a giant 1. X is equal to this. A right triangle. One angle is 70 degrees. So I'm going to put it like this. Right triangle. This is 70 degrees, about. And the side opposite it is 12. What is the length of the adjacent leg? So we'll call this X. 70 degrees is this one. I'm using my opposite and adjacent because I've got the opposite here and the adjacent. Those are the ones that I'm dealing with. I'm not even dealing with the hypotenuse, so I'm not going to use this. I'm not going to use this. This is the one. Let's see. The opposite over the adjacent, 12 is to X, is equal to 2.274, 2.747. Now, to solve this, I'll cross multiply, and I get 12 is equal to 2.747x. Divide both sides by 2.747. 2.747. You plug this into your calculator to get your x value. And any strategies that you use to solve this? Some questions to consider. Why does having the right triangle table give you enough information to find the unknown lengths and the angles in right triangles with only two other measurements given, either two sides or two angles, or an angle and a side. What are you good at using the table to figure out? What's hard about using the table for you? So here's the summary. Please read the summary. And then this last question. We're supposed to find the missing sides. And I'm going to do this one for you, and then we'll call it a day. So here we have, this is a 70-degree angle. And we're supposed to find the other angle, which would be 20, because these two have to add to 90. 90 plus 90 is 180. And from this reference angle, which would be this line, I've got the hypotenuse. So I'm looking for the adjacent and the opposite. I'm going to use these two columns. The adjacent would be this one. We'll call it X. This is the opposite. Let you go all the way across. And we'll call this Y. So my adjacent to the hypotenuse is X over 7. And for this line, that's equal to 0.342. The opposite to the hypotenuse would be Y over 7, which is equal to 0.940. And these, you can multiply both of them by 7 to get the X and the Y. And that's all we're doing, using the tables to find angles and to find sides. Good luck and success.